Okay, students, today's objective will use quadratic equations to solve real-world problems. For example 1, it says you're standing on the baseline of a tennis court and you want to practice your soccer skills. You want to kick the soccer ball from one baseline to the other, 78 feet away, but at the same time only clear the 3-foot net by 1 foot. The ball will travel in a parabolic path with the highest point being 1 foot above the net. So let's draw a picture. Here's my guy, and he is going to kick a soccer ball along the net, in a parabolic path, and he wants it to be 78 feet away. Okay, so let's label some points here. The soccer ball, we're going to label that at 0, 0. Give us a starting point. Now, if he is going to kick the ball 78 feet away, then this point over here where the soccer ball lands is going to be represented by the point 78, 0. Now, somewhere in the middle here is where the vertex of the parabola is. Now, it's got to be halfway between 0 and 78. So let's cut 78 in half, which would be 39. And what's the height of that vertex? Well, it says that at the same time he only wants to clear the 3-foot net by 1 foot. So that means if he's clearing a 3-foot net by 1 foot, that is a total of 4 feet high. Okay, so here's how we're going to label our vertex. Now remember, our vertex is H, K. We're going to need this in a minute. So we now have our picture, and that was part A. Okay, now let's move on to part B. Part B says, describe a reasonable domain and range. Okay, if you remember, domain is your x values. So in the x direction, how far is he kicking the ball? Well, he's going from 0 to 78. So remember, we write it as a between statement. Going from 0 to 78 feet. So this would represent my domain. The range, of course, is your y values. So at the bottommost point it's at 0. At the topmost point it's 4. So we're going to have a between statement. It's going to be 0. Y is going to be between 0 and 4. Okay, so now let's move on to part C. So I'm going to do that on the next page. Okay, so I've redrawn my picture up here at the top a little bit smaller so we can use it. In part C it says write an equation in vertex form relating the height of the ball to the distance traveled. So what we're going to use is what we talked about yesterday. We're taking a point, let's use 0, 0 because it's a little bit easier to use, and that's going to be my x and my y. We're also going to take my vertex, which was 39, 4. Now remember, that represents your h and your k. So let's go ahead and plug it into the equation because we're going to have to find a. My original vertex form, if you remember, is y equals a, parentheses, x minus h, quantity squared plus k. So let's plug in the x, the y, the h, and the k. So y is 0, and that equals a, parentheses. The x is 0, minus my h, which is 39, squared, plus k, so plus 4. Now go ahead and simplify it. So we have 0 equals a times a negative 39 squared, and then plus 4. So we have 0 equals negative 39 squared comes out to be 1,521. I'm going to put that in the front of a, and then I have the plus 4. We want to solve for a, so that means I need to subtract 4 from both sides. This cancels. We get negative 4 here, and that equals 1521a. Divide both sides by 1521, and now you have what? Excuse that distraction, my dog started barking. Okay, so let's finish this problem. We're going to have, excuse me, just a second. Okay, so we're going to cancel out the 1521, and that means that A is equal to negative 4 divided by 1521. Now, we're just going to leave it like that for now. So here's my A. Now let's rewrite the vertex form with all the information that we need from this problem. We're going to put y and x back in it, just the variables y and x. We're going to fill in numbers everywhere that we see the A, H, and K. Okay, so the vertex form is going to be this. Y equals my A right here, which is negative 4 over 1521, parentheses, my x minus h, so that was minus 39, quantity squared, and then we have plus 4. So this is your equation. Okay, part D says, is the vertex a maximum or a minimum? Well, remember, we're kicking the ball. It ends up looking like this. So the vertex is up here, and that means that it is a max. Okay, part E is for you to answer. It says, list the transformations in regard to the parent function. So I want you to tell me, remember, our parent function of the quadratic looked like this. So what happened from the parent function here to get it to look like this? And remember, the vertex was at 39.4. So what happened from this parent function to get it here? Please list that out and submit it in your Google Doc. The other thing that I would like for you to do is I want you to try and work through number 2 on the notes page on your own and come to class with it, and let's see how you do on your own.